We are starting with slide 38, and we're going to begin with kind of summarize the innate or non-specific defenses. First of all, the innate defenses do not distinguish between threats. Basically, just anything foreign, anything potentially dangerous or harmful, the innate defenses will attack. So the innate defenses include physical barriers like, skin and hair, and phagocytes. So macrophages and neutrophils are white blood cells that are phagocytes that will engulf foreign, substances, foreign pathogens, but just not in a specific way, just anything foreign. Then we have immune surveillance, and that, of course, is the NK cells. Interferons, complement, these are chemicals. Inflammation, which, inflammation includes the redness, heat, swelling, and pain, and then fever. So these are the categories of the innate defenses that we're going to learn about. For physical barriers, of course, the skin is the first primary physical barrier. The skin is coated with a protein called keratin, and hair, which is attached to the skin, acts as a physical barrier. Secretions from glands, like your oil and your sweat glands, will flush the surface of your skin and also contain destructive enzymes, lysozymes, and antibodies. And I'll go ahead and tell you specifically the antibody is the IgA antibody. Let me write that in here. That you're going to find in your oil and sweat secretions. Let me try it again. There we go. All right, so IgA stands for immunoglobulin A. Remember that antibody and immunoglobulin mean the same thing. So there's 5 classes of antibodies or immunoglobulins, and it's the IgA ones that are found in your sweat and oil secretions. And lysozymes are enzymes that also are found in sweat and oil secretions from your skin. So in addition, there are mucous membranes, and you find mucous membranes in your nasal cavity, the anus, respiratory tracts, nasal cavity again. Let's see. And so these mucous membranes also contain specialized enzymes, antibodies, and they have an acidic pH that will help to slow or kill off some of the bacteria or harmful substances, harmful pathogens. So, okay. And phagocytes are also a part of the innate defense. The phagocytes are the neutrophils, the macrophages, and the eosinophils. So phagocytosis means, phago means eat, cyte is cells. So these are the big eaters. And these are cells that can surround and engulf solid objects, like, for example, a bacterium. They're the first line of cellular defense, and in particular, the neutrophils are the first line of cellular defense against an infection. What they do is they remove cellular debris and microorganisms. They move into tissues by squeezing between capillary endothelial cells, so squeezing between the cells that form the smallest blood vessels called capillaries. This process where they do this is called diapedesis, where the phagocytes that are normally in the bloodstream can squeeze between the cells that form the capillary and enter the tissues. That's called diapedesis. And phagocytes are attracted or repelled by chemicals through chemotaxis. 2 phagocytes are neutrophils and eosinophils. These are white blood cells that leave the bloodstream, enter infected tissue to phagocytize, bacteria or other anyway, it is important that you know that neutrophils are the dominant phagocytes in the blood. And when we talk about the first line of cellular defense, neutrophils come first. But eosinophils are phagocytes also, and they function more in parasitic, like worm infections. And then we have phagocytes called macrophages, but they're much larger than eosinophils and neutrophils. They are derived from white blood cells called monocytes. Monocytes differentiate into macrophages in the tissues. Now, they can be fixed and they can be free. So some specialized fixed macrophages, we have the microglia, which you find in the CNS or central nervous system, and then Kupffer cells that are found in the liver. All right, we talked about NK or natural killer cells that function in immune surveillance. They just constantly monitor normal tissues. The plasma membrane of abnormal cells have non-self or foreign antigens. So this is, what I can relate this to is like your red blood cells, when you have a certain blood type, let's say your blood type A, that means your red blood cells contain A antigens on their surface. Well, all cells have particular antigens, which are just chemicals on the surface of the cell that your immune system can recognize. So foreign antigens are what our immune system is supposed to recognize and not self. It's self antigens, or our immune system is designed to leave those alone. But with NK cells, they recognize anything that isn't self. So they don't know specifically what it is. They don't recognize specifically whether it's a virus or a bacterium or a fungal infection. They just know it's foreign. They know it doesn't, this antigen is not one of our self antigens. And so the NK cells recognize the foreign antigen, such as the antigens found on the surface of bacteria, cells infected with viruses, cancer cells, will have different antigens on their surface than the normal tissue cells. And they respond very rapidly. They secrete these chemicals called perforins that create holes in the target cell's plasma membrane, and that will kill the cell. So that's what NK cells do. Interferons are cytokines, which are chemical messengers. They're released by activated lymphocytes. They're also released by macrophages and tissue cells infected with viruses. So they're especially associated with virally infected cells or virus-infected cells. The normal cell response to interferons is to produce antiviral proteins to interfere with viral replication so that the virus that is there can't make more virus, which is what makes you sick anyway. Slow the spread of viral infections, and also to stimulate macrophages and NK cells, which is an example of chemotaxis. Then we have the complement system, which is over 30 different plasma proteins called complement proteins. And the reason they're called complement is that they add to or complement the action of antibodies. So they do a lot of different things. One thing is they attract phagocytes. They stimulate phagocytosis. They destroy plasma membranes, and they promote inflammation. So they work in various ways to assist in our innate defense. Then we have the inflammatory response, and this is a response to a localized tissue response to injury. So it's just you have the inflammatory response if you if you burn your skin, for example, or if you have a tear, a wound of some kind, that you're going to have, your body's going to react, and the inflammatory response is going to be triggered when chemicals are released from the tissue that's injured. And also there are chemicals that will stimulate the inflammatory response. That would be histamine. which is released by white blood cells called basophils and also mast cells. So the 4 cardinal signs of inflammation are swelling, redness, heat, and pain. The swelling comes from the diapedesis, which is what happens when the blood vessels become more permeable and your macrophages and phagocytes your neutrophils, eosinophils, different phagocytes are able to leave through those endothelial cells of your capillaries. That process called diapedesis makes them leaky. They leak, they leak fluid, and that will lead to swelling in the tissues. The redness is because the capillaries or the blood vessels dilate, particularly around the area of infection, and that allows more of your immune cells and chemicals to get to the area of infection because the blood vessels dilating. So you have swelling, redness. The heat is from the increased blood flow to the area, and the pain is just from the swelling where it pushes on nerve endings. So swelling, redness, heat, and pain, the 4 cardinal signs of inflammation. Inflammation happens due to the release of histamine, which leads to the 4 inflammatory response signs. And then heparin is also generally released along with histamine, and it prevents blood clotting. Since there's increased blood flow, it just prevents blood clotting. It's a blood thinner. All right, then we have the inflammatory process. So first you're going to have some kind of injury to a tissue, and that leads to those tissue cells are going to produce histamine, which leads to increased blood vessel permeability, and that's going to allow white blood cells to migrate out of blood into tissue. And this is the word for this, remember, is diapedesis. And because of this increased blood vessel permeability, we also can have plasma leaking out. That's going to lead to your swelling or edema. So more blood flow to the area is what causes the redness and the heat. The swelling or edema comes from the leakage from the diapedesis, and the pain is from the swelling. Then you can have after the inflammatory response, then you can have tissue destruction called necrosis, tissue death, and pus, which forms at the site of inflammation, a site of infection a lot of times. It consists of dead and dying cells and debris accumulating at the injury site, and then fluid. All right, fever also happens as one of our innate defenses. It is defined as a body temperature of greater than 37.2 Celsius or greater than 99 degrees Fahrenheit. That's technically a fever. Pyrogens are proteins that reset the temperature center in the hypothalamus, and that causes body temperature to raise. Mild fever is beneficial. You may have heard this, that sometimes when you see that you have a fever, your first instinct is to take your Tylenol or whatever to lower that fever. But a mild fever is beneficial. Then it increases your metabolism and helps the healing process. However, a high fever is defined as 104 degrees Fahrenheit or above. And that can damage physiological systems. That can lead to death. So that has to come down. But a mild fever actually helps with the innate defenses. This is slide number 48, which shows the steps in inflammation. I'm going to blow it up so we can see it a little better. So we have, looks like something is sharp just stuck into the skin. So it's pierced the skin. And so here we have tissue damage. It pierced into the epidermis and then down into the dermis. So it's caused tissue damage. That's going to activate mast cells, which release histamine and heparin, which are going to stimulate the inflammatory response and also prevent blood clotting. So that's going to lead to the release of histamine and heparin is going to lead to the redness, swelling, heat, and pain. The redness and heat is from the dilation of blood vessels. The swelling is from the blood vessels becoming more permeable or leaky. We call that diapedesis because they allow some of the white blood cells, the phagocytes, to leave and enter the tissues and help, to fight the infection. And the pain is due to the swelling. So there will also be, due to this release of histamine and heparin, there will be the attraction of other phagocytes, and that will lead to the release of cytokines like interferon, the removal of debris by neutrophils and macrophages, and then that will lead to the process of tissue repair.